In homework 13, we want to look at solving radical equations. These are equations that contain radicals. Now, the property that we use here is called the power property. And basically what we do is that we get to say that if you have a equals b, then you can raise both sides of the equation to the same power, and you can still find solutions to the original equation. You just have to be careful, and you actually have to check your solutions. And you don't want to use the power property until you have a radical by itself. So in this first equation, we need to get this cube root by itself. And that can be easily accomplished by moving the 6 to the other side. So by subtracting the 6, we have -5. Now, it's all about undoing what's being done to x to get it by itself. So the opposite of taking the cube root is raising to the third power. The power property, the power needs to match up with the index. So this gives us x plus 7 equals -125. And then we just solve this equation. Get x by itself by subtracting 7 from both sides. And x equals -132. And you'll see that if you plug this back into the original, you would have the cube root of -125, which is -5, plus 6 would equal 1. So everything's good for this one. And those guys are usually not the ones we have problems with. It's the ones with the square root, so we have to be very careful. Now, number 2, notice that you already have a radical equal to itself. Well, the way to cancel these square roots is to raise both sides to the second power. When we do that, we have 5x minus 71 is equal to 2x plus 25. This is a nice linear equation, so I'm going to move this over here as a -2x and move this over here as a positive 71. So we have 3x is equal to 96. Finished getting x by itself, so x equals 32. Now with square roots, you always want to make sure that the solution does check out. Sometimes we have these weird situations happen. So let's check this. We need to see if 5 times 32 minus 71 in the square root is the same as 2 times 32 plus 25. Well, 5 times 32 is 160. So 160 minus 71. And this gives us 89. On the other square root, we get 64 plus 25 inside the square root, and that equals 89. So we see that they both work out. They both end up being the same thing. So x equals 32 is the solution. But now let's look at number 3. Let's look at this problem. In number 3, we have the square root of x plus 5 is equal to x plus 3. Well, the radical is already by itself. And the power that we would use to cancel that is a square, because it's the square root. And then you have to square the other side. Now notice you square the side, not each term. On the left side, this reduces to give you x plus 5. On the right side, x plus 3 would actually multiply to give you x squared plus 6x plus 9. Well, this equation is quadratic, so I'm going to have to move everything to one side. So I end up with 0 is equal to x squared plus 5x plus 4. Nice quadratic equation. Should be able to solve this guy by factoring. And he factors as x plus 4 times x plus 1. using the zero factor theorem, yields solutions of -4 or -1. But you have to make sure that you check these. If I check this guy right here, if I plug in -4, is the square root of -4 plus 5 equal to -4 plus 3? Well, this guy is the square root of 1, but the other side is -1. These guys are not equal. But remember, the square root symbol is just the positive or the principal square root, so this guy doesn't work. So we have to call this guy what he is. And this guy would be extraneous. You didn't do anything wrong, but the limitations of the original problem with the square root symbol mean that it just doesn't work out. But check this guy, -1. Is the square root of -1 plus 5 equal to -1 plus 3? Well, this is the square root of 4. Does that equal +2? And the answer, of course, is yes. So x equals 1, or excuse me, x equals -1 is the only solution that we have here. So always make sure you check your solutions. All right, let's look at number 4. Now, I told you that you need to get one of the radicals by itself first. So we can easily accomplish that by moving this guy over. So the square root of 2x plus 1 is equal to the square root of x plus 1. When you're trying to isolate a radical, you really want to isolate the more complicated radical first. Then you apply the power property, so I raise both sides to the second power. And that gives me 2x plus 1 on the left side. On the right side, please understand that this is just like a plus b squared. And when you have a plus b squared, this is the special product that gives you a squared plus 2ab plus b squared. So if I square this guy, I get x. If I square the 1, I get 1. It's that 2ab part that messes with people. Just look at it this way. What's the square root of x times 1? The square root of x. Multiply times 2, so you get 2 square roots of x. It just says multiply a and b together and double it. That's all. Now, you had 2 radicals to start. Now you only have 1. Get this radical by itself. So, get rid of the riffraff. So, minus x and minus 1. That leaves me with just x is equal to 2 square roots of x. Now, I could divide by 2, but I don't want to have fractions, and it would be better for me to just go ahead and use the power property again. So when I do that, I end up with x squared is equal to, now be careful, you square the 2 to get 4, you square the square root to get x. Now we can square each of these pieces because it's a product, they're stuck together. So it's not like the special product up here that had addition separating 2 terms. This equation is quadratic, so we get everything to one side. We factor by taking out the GCF. Always look for the GCF first. And then it's just a matter of solving this. So x equals 0 or x equals +4. So let's go back up here and check this. If I check 0, 0 is actually pretty easy to check. So plug in 0 right here. That's 0 plus 1, so that's 1. What's the square root of 1 minus the square root of 0? Well, that's 1 minus 0, which is 1. So I know that x equals 0 is true. If I check x equals 4, so I want to check this guy, is the square root of 2 times 4 plus 1 minus the square root of 4 equal to 1? 2 times 4 is 8 plus 1 is 9, so is the square root of 9 minus the square root of 4 1? 3 minus 2 equals 1. That checks out. So both of these are solutions.